Mayon Volcano is erupting right now, and what is happening on its slopes has scientists scrambling, emergency managers sleepless, and over 4,000 people fleeing for their lives. Because this isn't just another eruption. The numbers coming out of the Philippine Institute of Volcanology and Seismology are unlike anything recorded in recent memory. Dozens of pyroclastic flows in a single day. A lava fountain shooting 100 meters into the night sky. A summit dome glowing so bright it's visible with the naked eye from kilometers away. And underneath all of it, a magma system that is pressurizing, inflating, and pushing relentlessly toward the surface. The question isn't whether Mayon is erupting, it already is. The question that is keeping volcanologists awake at night is what comes next, because history has a very specific and very brutal answer to that question. And if the current signals are pointing where scientists fear they might be pointing, the communities surrounding, this perfect volcanic cone could be facing something catastrophic. This is the story of the Philippines' most active volcano, a geological titan that has killed thousands across 5 centuries of eruptions, and what its violent awakening in early 2026 means for everyone living in its shadow. To understand why Mayon is so terrifying right now, you first have to understand what makes it different from almost every other volcano on Earth. Mayon is what geologists call a stratovolcano, a layered cone built up over tens of thousands of years by successive eruptions, each one depositing another skin of hardened lava, ash, and rock. This process produces the iconic symmetrical shape that makes Mayon one of the most photographed natural features in Asia. Rising 2,463 meters above the Albay Gulf in a near-perfect cone, it looks almost sculpted, almost artificial in its geometry. But that beauty is deceptive. The same layering that creates the elegant shape also makes the edifice fundamentally unstable. Mayon exists because of its position on the Pacific Ring of Fire. Specifically, it sits above a collision zone where the Philippine Sea Plate is grinding beneath the lighter Eurasian plate in a process called subduction. As the heavier oceanic plate plunges into the Earth's mantle, rock melts under immense heat and pressure, generating magma that is less dense than the solid rock around it. That magma begins to rise. It collects in chambers beneath the volcano. It pushes upward through conduits, accumulates pressure, and eventually forces its way to the surface. This has happened more than 50 times in the last 500 years. Mayon has never truly stopped erupting. It only pauses. What changed dramatically on January 6th of this year was the nature of the activity. The Philippine Institute of Volcanology and Seismology, known as PHIVOLS, raised the alert level from 2 to 3. This is not a routine upgrade. Alert level 3 means a magmatic eruption is already underway and a larger explosive event is possible within days to weeks. It is the threshold that triggers mandatory evacuations, that locks down the permanent danger zone, and that puts emergency systems across Albay province on a war footing. And what triggered it was something that volcano scientists watch with particular dread: the collapse of the summit lava dome. Picture what is happening at the top of Mayon right now. Thick, degassed magma has been rising slowly through the volcano's conduit and piling up at the crater, forming a dome of new, unstable rock. This dome grows under its own pressure, building outward and upward, but its own weight becomes its enemy. Gravity eventually wins. Sections of the dome fracture and break away, and when they do not simply roll down the slope, they disintegrate. They transform instantly into what scientists call pyroclastic density currents, what the local people call akyat apoy, rivers of superheated gas, ash, and volcanic rock that race down the flanks at speeds exceeding 100 kilometers per hour and temperatures approaching 1,000 degrees Celsius. There is no surviving a direct encounter with a pyroclastic flow. They are the most lethal phenomenon in the volcanic world. The numbers coming from the monitoring network between January 12th and 13th alone tell the story of a volcano in violent, continuous motion. 206 separate rockfall events recorded in a single day, 63 pyroclastic density currents cascading down the slopes. This was up from 37 the previous day. And these flows didn't happen at random. They channeled through Mayon's 40 or so natural ravines, the gullies that radiate outward from the summit like spokes on a wheel. Each one acts as a natural cannon, focusing the deadly currents directly toward the inhabited lowlands below. Then, at exactly 1:39 in the morning on January 13th, something that no one who witnessed it will soon forget. For 35 seconds, a fountain of incandescent lava erupted from the summit crater, shooting 100 meters into the night sky. 35 seconds doesn't sound long, but in volcanic terms, a lava fountain of that intensity is a direct window into the pressure, building inside the system. It is the volcano showing its hand, telling anyone paying attention that the magma below is fresh, gas-rich, and moving. All of this was confirmed by the instruments on the ground. The volcano's edifice is inflated. Ground deformation sensors and GPS networks show that the entire structure of Mayon has swollen outward, the physical signature of magma pushing up from depth. Sulfur dioxide emissions hit 777 tons per day on January 10th. Another indicator that fresh magma with dissolved gases is near the surface and degassing actively. Seismic stations across the monitoring network recorded a sharp increase in volcanic earthquakes, the kind of small, shallow tremors that mark magma forcing its way through rock. For PHIVOLC scientists, every one of these data streams points in the same direction. The system is pressurizing. The dome at the summit is in a dangerous cycle of growth and collapse. And the question hanging over every briefing, every bulletin, and every conversation in the monitoring center is whether this cycle is a sustained but manageable eruption or the precursor to something much larger. To answer that question, you have to look at what Mayon has done before. The volcano's historical record is not just a list of events. It is a warning written in ash and stone. The most devastating eruption in recorded history came on February 1st, 1814. On that day, a Plinian eruption, the most violent category possible, sent a column of ash and rock high into the atmosphere. Pyroclastic flows swept down the slopes and buried the town of Kagsawa. Approximately 1,200 people died. The only thing left of the town today is the stone bell tower of its church jutting from the ground like a headstone, a monument to what Mayon is capable of when it fully unleashes. In 1993, without significant warning, an explosion generated pyroclastic currents that killed 77 farmers working on the volcano's slopes. Not living nearby, working on the slopes. In 2006, a typhoon hit the region and triggered massive lahars on Mayon that buried entire villages and killed over 1,200 people. Not from a new eruption, from volcanic material that had already been deposited on the slopes by past activity, remobilized by heavy rain. The 2018 eruption featured lava fountains, large ash columns, and pyroclastic flows that forced the evacuation of tens of thousands. The pattern is unmistakable. Mayon can escalate without warning. Its pyroclastic flows are consistently its primary killer, and its danger does not end when the eruption stops. That last point is critical to understand right now, because even as emergency managers focus on the immediate threat of pyroclastic currents, a second weapon is being loaded: lahars. These are fast-moving volcanic mud flows that form when heavy rainfall mixes with the loose ash and rock being deposited on the slopes by the current activity. Every pyroclastic density current that races down a ravine leaves behind a fresh layer of unstable material. Every day of elevated activity adds more. This material sits on steep slopes, ready to mobilize the moment significant rainfall arrives. In a region like Albay, where typhoon season is a fact of life, that rainfall is not a question of if, it is a question of when. And when it comes, the lahar threat could persist for months or years after the eruption itself has ended. For the 3,516 people already evacuated from the 6-kilometer permanent danger zone, the present reality is evacuation centers. Schools and community halls repurposed into shelters. Families who gathered what they could carry and left behind homes, fields, and animals. As of the latest reports, the number of affected individuals has climbed past 4,100. 13 barangays have been emptied. Over 900 families are sleeping on cots and woven mats, waiting for a volcano to make up its mind. Children whose school calendars have been suspended. Farmers who left their fields at a critical point in the growing season, watching from a distance and calculating the economic damage already done. This is the agonizing reality of living in Mayon's shadow. The volcano's slopes are incredibly fertile. The same geological violence that makes the eruption so destructive also creates some of the most productive agricultural land in the Philippines. Generations of families have farmed this soil, built their identities around it, and made peace with the risk. For many, leaving is not simply a matter of relocating. It is abandoning a way of life that stretches back through their family history further than they can trace. The pull of home, of crops in the field, and livestock in the pen is powerful enough that authorities have deployed hundreds of police officers to enforce the danger zone boundary, because some people will go back, and some of them will not come out. Back at the monitoring center, the surveillance network watching Mayon is operating at full intensity. 16 seismic stations track every tremor, every pulse of volcanic energy. GPS receivers and tilt meters measure the ground's movement in real time, watching for any change in the rate of inflation. Gas analyzers sample sulfur dioxide output, searching for the spikes that indicate fresh magma surging toward the surface. Satellite imagery and drone feeds provide views of the dome, tracking its growth and watching for signs that a major collapse is imminent. Right now, Alert Level 3 is holding, but the threshold for Level 4 is clearly defined, a dramatic increase in the frequency and reach of pyroclastic flows, sustained and powerful lava fountaining, major escalations in seismic activity or ground deformation. If those signals arrive, the danger zone expands to 8 kilometers or more. The evacuation order extends to an additional 79,000 people. In the entire response, apparatus shifts from managed emergency to full-scale crisis. That is the scenario 5 scientists are working to predict, and the one that emergency planners in Albay are quietly preparing for. The resources are being positioned. The evacuation routes are mapped. The centers are being identified, because the history of this volcano teaches one lesson above all others. When Mayon decides to escalate, it can do so faster than people can react. There is something almost impossible to reconcile about standing in Albay and looking up at Mayon. The cone is stunning, its slopes green and terraced with farms, its summit frequently wreathed in cloud, the perfect geometry giving it an almost serene quality from a distance. And then, at night, the dome glows, faintly but persistently, a reminder of the fire that is always burning just below the surface. The people of Albay know this glow the way people in other places know the weather. It is part of the landscape, part of life, and that familiarity, that acceptance, is both a form of resilience and a form of risk. Because Mayon does not ask permission, it does not follow a schedule. The 1993 eruption killed farmers who had worked those slopes for years without incident. The 1814 eruption erased an entire town in a matter of minutes. The volcano has been erupting in some form for as long as human memory in this region extends, and it has always come back larger than anyone expected. The dome is growing. The pyroclastic flows are accelerating. The ground is inflated. The seismicity is rising. And more than 4,000 people are sleeping in evacuation centers tonight, watching the glow on the horizon and waiting for the scientists to tell them when it is safe to go home, if it ever is. This is Mayon in 2026, a volcano that has never truly slept, momentarily awake in a way that is putting an entire region on edge. The monitoring network is recording everything. The scientists are watching every data point. The Emergency managers are staging every resource, and the mountain is telling its own story in the language of fire and pressure and gravity to anyone willing to listen. The question is not whether Mayon will erupt more violently. The question is when, and whether the warning will come in time.